In the previous video, we covered tool parameters for drilling, and we looked at how to customize tool images. This one will continue with tool parameters and talk about setting up router bits. As we open up the program, then we'll explain the router bits. And like drills, the routers are broken up into the face that they work on. Straight router bits that work only on the top face, and a router bit that can work on face 1, 3, 4, 5, or 6 would be an aggregate, or possibly a 5-axis machine that can work on any of the faces of the panel except the bottom. So let's look at a more typical face 1 router bit. These are broken into straight tools, profiled, and bullnose tools. Straight tools is the most common, and let's look at one of the tools here. And like drills, you can take an existing tool and edit it if you want, or you can simply go to the add button and start over with a new tool. So if we start off with this tool here, that we'll go through its parameters. One big difference between routers and drills is that you have to specify a tool ID or a tool number. And the tool number has to be 4 digits. It can be any 4 digits, and it doesn't have to be correlated to the tool position on the tool changer at all. It can be any 4-digit number. Then we can specify a comment, just like we did with drills, and then we'll define the tool length, and that is measured in most cases when we've got the tool in a tool holder, an HSK holder. Then we measure from the shoulder, just that mates up with on the underside of the spindle, but this shoulder on the tool, just as it's drawn here, is the entire tool length. So we measure from there to the tip of the tool to get our entire tool length. Be sure to factor in this part of the tool. If you measure the tool too short, then you can make the tool go too deep into the material. So remember, you have to factor in from the shoulder of the holder all the way down to the tip of the tool. Sometimes you may have to make 2 measurements with your calipers. If you have calipers that are long enough, you can actually measure from the tip of the tool all the way to the very top of the tool holder, which isn't shown here. And on an HSK holder, it's always 25 millimeters from this shoulder to the very top. So you can measure the entire tool length, holder and all, and subtract 25, or if your calipers aren't long enough, you can make 2 measurements. But in any event, get in your tool length, your diameter, minimum and maximum RPMs, and like drills, there's no reason to turn the maximum RPM, typically is 24,000 RPM. And of course, with router bits, you're going to typically, with most wood materials, you're going to operate somewhere between 15 and 18,000 RPMs as a default, but you can go faster. It's important to always use this maximum RPM as a safety feature. If you have a tool that's larger, and you should have a recommended RPM from your tooling vendor. If you don't, then ask them what that maximum RPM should be. But for larger tools, you should always pay attention to that maximum RPM. And if they recommend that, say it's a maximum RPM of say 16,000, then set your maximum there. Even if you've got your default at 15, you don't ever want that tool to go faster than the maximum. And if you set your maximum and you try to set the program to go faster than the maximum, you'll get an error message, and the machine will not go faster than the maximum. So use that to your advantage. It's a safety feature. The rotation refers to the rotation that the spindle turns. Most common is right-hand rotation, which is M03. M04 is a left turning tool. It's not quite as common. Even less common is a tool that can turn left or right. The software is able to handle tools like that. So the next parameter is the feed rate, and again, this, like drills, these parameters, lengths and feed rates, are in metric. When we get to feed rates, we're talking about meters per minute. If you think in inches per minute, like a lot of us here in the States do, then a pretty quick and dirty factor to go from meters per minute to inches per minute is 40. It's actually 39.3 or something like that. But if you just use 40, then 8 meters per minute loosely equivalent to 320 inches a minute. The penetration speed is just how fast we go from our positioning speed over the panel into the panel. Enabled connections is not something we have to use. It gives you more control over the speed of the tool around the corner, and it's typically only used for large diameter tools. For most of our straight tools, we don't need to use this. The machine does a good job of automatically managing the feet around the corners, but you can use this if you think that you have a special tool that requires it. The acceleration and deceleration typically is going to be between 3 and 4 seconds. This refers to how long it takes the inverter to ramp the spindle up to speed or from speed down to 0. And so you don't want this too fast, because for a larger diameter tool, the inverter tries to break it too fast, you can overheat the inverter and possibly get an error message. So for most of your straight tools, your straight carbide tools with no profile, 3 seconds is fine. For larger diameter tools, such as a surfacing tool for a nested base machine or any insert cutter, then 4 seconds is more typical. Or if you have some other tool that's a brazed on smaller diameter carbide tool, then 3.5 would be okay. The clearing quote is a dimension or a parameter you can put on the tool that will make it rise above the panel by a specified amount, in addition to the global parameter we call the air gap, which we'll look at later. So every tool has a global parameter to pull above the panel before it positions. Typically that's 10 millimeters. But let's say you had a tool that was, say a larger tool that was bolted onto a shaft, and to hold that tool onto the shaft there was a large nut on the bottom of the tool. So you would want to factor that in, and let's say that nut was 15 millimeters. So if you gave the clearing quote 15 millimeters, then the tool would pull above the panel by 15 millimeters for the clearing quote, plus the 10 for the air gap at all tools. So this is a way that you can factor in some part of the tool that you don't cut with, that you don't want to have to factor into the actual tool length. This clearing quote will keep it above the material safely. And like with drills, we can go into the images and we can choose any of the unused or any of the images that are not red, or go down to the unassigned images and pick any of those. Or we can also edit any of these as we did in the previous video. So select your image. You can also use a photo of the tool if you'd like to do that, but it's not as common. But you can take a picture of your tool and import that image here. So between that's the how to set up straight router bits. It's worth mentioning profiled router bits is the same parameters, and one parameter of note under a bullnose tool that's different from straight or profile tools is that the tool length is measured as before from the shoulder of the HSK tool, but instead of going to the bottom of the tool, it goes to the middle of the profile. So if you have a bullnose that you want to put on the center of your part, then you'll write a program to tell it to go to the middle of the thickness, and it'll put the middle of the tool on the middle of the part, which is typically what you want with a bullnose. So with bullnose tools, you have two lengths. You have a tool length, which is measured from the shoulder to the middle, and then you have a working length that's measured from the middle to the bottom. And you still also have a clearing quote if you want to use that too. But this feature makes it really easy to locate a bullnose tool right on the middle of the edge of a part. This parameter, this working tool length and working length, is different than in the other tools. All the other parameters are the same. And finally, we have saws. And saws are there are different types of saws. On this machine, we have a saw that works only in the X direction, and you have the typical parameters for it. It's saw the diameter of the saw, the maximum depth that it can cut, the saw thickness, and the offset Y. This OFSY, this parameter refers to the distance from the middle of the tool out to the edge if you have a tool that's rotating or has two edges. You've got your minimum and maximum RPM, and there's two other parameters that are very important. The rotation is simply that. If we typically don't need to change the rotation of the saw, especially if we're drilling at the same time. We don't like to have to stop the drill motor and reverse its rotation. So typically the rotation you'll leave as it was set from the factory, but the saw rotation direction is not at all what it sounds like. The saw rotation direction controls which direction the saw feeds in. Obviously a saw should always climb cut. So if you're depending upon the direction of the saw teeth, then once we get our saw mounted onto the machine, then we can use the saw rotation direction to control whether the saw cuts from left to right or right to left. And regardless of how you write the program, whether you tell it to start on the right and go to the left or vice versa, it doesn't matter how you program it. With this parameter, the machine will only cut one direction. So once these parameters are set correctly, then you don't have to worry about programming the saw to cut in the wrong direction. It won't do it. It'll always cut in the correct direction once you have these parameters set correctly. And you also have the same work speeds and penetration speeds like other tools.